Today we're talking about Chapter 9, Section 2, Compound Statements and Connectives. Connectives, not connectives. But yeah, just connectives. Alright, I'm not going to read all that. Instead we're going to get to the meaty stuff. The and statement. Alright, so today what we're going to do is we're going to talk about, maybe I'll skim, let's skim the first page actually, see if it could lead me here. Well, alright, so what we're doing today is we're going to be taking sentences and basically translating them to um, logical statements using, again, kind of variables, right? P, Q, R, things like that. We're using variables and something called connectives. And connectives being down here and, or, if then, and if and only if. We're going to be constructing sentences, or I'm sorry, rather, we're going to be constructing logical statements from our sentences. So I will admit today might be a lot to wrap your head around because today is a lot of stuff. But obviously these lectures are recorded and you can always go back and watch them. So the first thing we want to talk about, looking at the top there, and statements. So if P and Q, so again I'm right here, if P and Q represent two simple statements, then the compound statement P and Q is symbolized by P and then a little peak Q. The compound statement formed by connecting statements with the word and is called a conjunction. And the symbol for that is just simply the little TP. Okay, and we're going to get to an or right after and. An or is going to be a V. Okay, so how do you memorize and or? Well, and kind of looks like and, just like that, looking like an A. And we'll touch on that here in a moment. Let's start out. So example 1, we're going to let P and Q represent the following simple statements. P is going to mean it is after 5 p.m. Q is going to mean they're working. So A wants us, so write each compound statement below in symbolic form. A wants us to write it is after 5 p.m. and they are working. Okay, so it is after 5 p.m. Well, that's just P. And, okay, they are working. So Q. So it just looks like this. P and Q. Next up, we have it is after 5 p.m. So that's, again, same thing. We're going to say P. And they are not working. Okay, so and, same conjunction there. And they are not, so a little squiggle, they are not working. Right. And that's it for and, really. I mean, there will be statements, where we have, it is not after 5 p.m. and they are not working, which would just simply be, since I went ahead and did that. If it is not after 5 p.m. and they are not working, then we would say not after 5 p.m. and they are not working. Right, some of the ways that and can be worded, and again, many of you are very familiar with this because you've spoken the language for quite a while. So other ways to express, P and Q. So all these are P and Q, right? You could say P and Q. You could say P but Q. You could say P yet Q, and then P nevertheless Q. Right? All these mean the exact same thing. It's just different words are used, but in the end, it means P and Q. All right, so I want to put the or statements. Let's see. Yeah. Okay. So I want to combine. I want to make sure that the or statement is paired up with the actual example with it. That way, whenever you do look at the notes, it's just like, oh, okay, so this is it. This is how we do it. So starting at the top here, we have or statements. So the connective or can mean two different things. So for example, we'll consider the statement, I visited London or Paris. This statement can mean that I visited London or Paris, but not both. Okay. Again, it's just I visited London or Paris. That's about as simple as it gets, right? This is an example of an exclusive or, which means one or the other, but not both. Right? This is an example of an inclusive statement. Right? Down here, the symbol for this is going to be that V that I talked about briefly. It's going to be a V, and again, and is going to be the A without the little line in the middle. Right? Thus, we can symbolize a compound statement P or Q or both by P and then the V, Q. Right? So let's look at this example. So it reads, let P and Q represent the following simple statements. P is going to mean the bill received majority approval. Q is going to mean the bill becomes a law. So let's write each compound statement below in symbolic form. So A reads, the bill receives majority approval. Okay, so that's just simply P. Or the bill becomes law. So we put or the bill becomes law. And that's it for that. B, the bill receives majority approval. So same thing, we're going to start off with a P. Or the bill does not become law. So we put a not becomes law. Right? So that's the gist of and or. Basically, you honestly just read the statement and then you put the and or the or statement, um, respectively, depending on your problem. All right, next up, now we're getting into the things that will be a little tricky, um, and I know they'll be a little tricky. Not necessarily tricky in a sense that they're brain teasers, but just kind of um, things to remember, honestly. I remember when I was taking this, and I was just like, oh, geez, all these symbols, all these things. And as a matter of fact, I've had a particular student also talk about all these symbols and things. So uh, I was there, I understand, and at the end of the class, I promise you're going to be like, Dadgum, I actually learned a lot of useful stuff in this particular course. But that out of the way, let's continue. So next up, we have if-then statements. Right? We've made if-then statements our entire lives, right? If it's not raining outside, we'll go to the store, right? Or if it's not raining outside, then we'll go to the store, something like that. So if I were to put that into a logical statement, right? Just looking at this bold here, the compound statement if P then Q, we symbolize it with just the arrow, just an arrow. That's it. The arrow represents in itself, it represents if then, and that's really it. I will say this. Um, I think I might have told. I don't know if I told you individually or told you as a class, but the day I passed English Comp 2 was like a top 5 day of my life. So whenever I'm looking over this course and I come across antecedent and consequent, I immediately felt a sense of dread. But it's I don't think it's necessarily pertinent to this particular course. It's just these statements, these words, this procedure, they have definitions and words connected to them. And in this particular case, it's just antecedent. If antecedent, then consequent, and that makes sense, right? And in case you're wondering, uh, ante, ante, that means before. Okay, all right. So uh, let's begin. Example 3, let P and Q represent the following simple statements. So P reads, a person is a father. Q reads, a person is a male. So let's write each compound statement below in symbolic form. Okay. So A, if a person is a father, then that person is a male. Okay, so we're going to say person is a father, and that person is a male. Right? Doesn't get too much easier than that. B, If a person is a male, then that person is a father. So same thing, it's just we're flipping it this time. So if a person is a male, then that person is a father. Right, and then we're going to mix in some knots, I believe. Yeah, we're going to mix in some knots there. So if a person is not a male, so we're going to say squiggle Q. So a person is not a male, then that person is squiggle P, not a father. Okay. So far, let's just try to let's do this. So far, we have a couple of things to remember. We have to remember and, we have to remember or, and we have to remember if then. So if this, then this, right? Uh, and of course, we have the squiggle, which is the negation. So far, that's really all we have to memorize. Um, but again, things are going to get a little more complicated, and that's just the way it is. But so far, hopefully that's just to catch up. So similar to other statements that we've seen, there are multiple ways to say if then. And I believe we also have another table on the next page. No, we don't. Never mind. Okay. So similar to, oh, did I even snip that? I don't guess. Okay, so there wasn't a table for or. Okay, never mind. Just making sure. So similar to different ways we can say and, there are multiple ways that we could say if then. Right? So of course we have the if p then q. We have uh, p if p then q can also mean q if p. Right? Remember now we're taking out the then, but so a person is a male if that person is a father. So it's just simply an if in there. Okay. And then P is sufficient for Q, same thing. Q is necessary for P, and I believe we'll need to touch on sufficient and necessary. I think we'll touch on sufficient and necessary next week. Uh, P only if Q, and then only if Q P. So there are multiple ways, and again, as you know, you've done this multiple times without even realizing it. But there are multiple ways to go about saying in each individual statement. All right. So example, yes. Uh, yes. If X, then Y, the symbol is always going to be an arrow every single time. Okay, and we'll talk about that when we get to another connective. I think it'll be in the next example. But these are connectives, right? So up until now we talked about just basically the connectives and or. Well, the connective if this then this is always going to be an arrow, and then we'll also see another one which is an if and only if, which I think will be after this example. So let P and Q represent the following simple statements. So P, we suffer huge budget deficits. Q, we control military spending. So we need to write the following compound statement in symbolic form, right? So this is just there's no A or B, we just have to write in symbolic form. So the statement is controlling military spending is necessary. So let's go back. Um, right here we have the is necessary. Okay, and it is an if then statement, right? P implies Q. That's another way to put it. P implies Q. Uh, so Q is necessary for P, so that's what we're going to look at here. So it says controlling military spending is necessary for not suffering huge budget losses. Okay, so we're still going to use the same procedure here, right? Because looking here, it's still P implies Q. Okay, Q is necessary for P is the same thing as P implies Q, and this particular problem has, Q is necessary for. Right. However, what we're going to do is we see that we have a not for not suffering huge budget deficit. So we're going to put a squiggle in front of P. Okay. And well, that's it. So again, all we did was we just went back to our table that we referenced. Does this need to be memorized? Not necessarily. Logically, it also makes sense. I just went back and showed you how it connects to the table. And let's actually erase it off the table real quick. I said it because I know that you're probably thinking, crap, something else I have to memorize, right? But if we think about this logically, right? So controlling military spending, it is necessary for not suffering huge budget deficit. So if it is necessary for not suffering huge budget deficit, and huge budget deficit is P, well then again the same logical step would be, okay, so we're still in the realm of P needs to be we need to have P before we can even get to Q, right? So the is necessary for, again, we don't necessarily have to use a table. It's just one of those logical statements that I do feel like you can come up with on your own. Right, now we get to the if and only if statements. Right, so you may have heard the statement if and only if at some point in your life, and you might have even used it at some point in your life. And if you were like me, you might have used it incorrectly. Um, as a debater, I I thought it sounded like, hey, I know what I'm talking about. Shut up. Um, but it doesn't really mean that. It actually means it means both conditions have to be true. And of course, we can see this up top. So right here, start from the tippy top, an if and only if statement. So if a conditional statement is true, then reversing the antecedent and consequent may result in the statement that is not necessarily true. Okay? So if a person is a father, then that person is a male. If a person is a male, then that person is a father. Okay? So again, if we're doing the then it's not necessarily true. So it's saying, let's write this in letters here. It is saying if P implies Q, it is not necessarily true that Q implies P. Okay, so again, in this particular example was if a person is a father, then that person is a male, and if we reversed it, if a person is a male, then that person is a father. Of course, we see that is not necessarily true. Okay, so the symbol we're going to use to make sure that let me go back for it. The symbol we're going to use to make sure that something like this is true, right? So if P implies Q and Q implies P, then the symbol is going to be an arrow going both ways. And let's proceed here. That's not what I wanted, so proceed here. So, however, some true conditional statements are still true when the antecedent and consequent are reversed. So, if a person is an unmarried male, then that person is a bachelor. If a person is a bachelor, then that person is an unmarried male. So these are true. So what we're looking at here is a biconditional statement. This biconditional statement, phonetically, we say if and only if. Okay, and then the symbol, as I put over here, is just simply an arrow pointing both ways. This is a biconditional statement, and it is phonetically um, pronounced if and only if. And it means that it works both ways. It means that P implies Q and Q implies P. Okay, so let's look at the example. Example 5. Tables. I don't even think I need the table. No, I don't really need the table. But here's the table. It just shows what words have the most definitions. Anyways, table 6 shows that the word set has 464 meanings, making it the word with the most meanings in English language. So we're going to let P and Q represent the following simple statements. P is going to mean the word set, and Q is going to mean the word has 464 meanings. So write each of the compound statements below in its symbolic form. Okay, so here we go. A reads the word set. The word is set if and only if the word has 464 meanings. So the word is set, and of course that corresponds with P. And then we have if and only if. We have this. That's horrible. Let's fix that. Like that. So again, that is the word set if and only if the word has 464 meanings. B, the word does not have 464 meanings if and only if the word is not set. Okay, so the word does not have 464 meanings, and that corresponds with Q. If and only if, so we're going to put our if and only if statement, or I'm sorry, symbol. The word is not set, so we're going to put not P. Does no, it does not actually, because it is an if and only if statement. In this particular case, we're just following the sentence left to right. Since it is an if and only if statement, and since it's true forward and it is true backwards, this statement down here could also read, the word is not set if and only if the word does not have 464 meanings. Mm-hmm. All right. All right. Now we are going to get into some horrible stuff. This is where we have to group things. And again, I'm only saying that because I do feel like it's just a lot. All right, and this down here actually, let's put this on the previous page actually because it corresponds with the question that was asked. If I have room, um, it'll, no, just make it smaller. And again, these kind of notes you can find on your homework as a slideshow. I forgot what they're called, but they are there. However, the thing I want to point out here, and it's really small, but we see that down here, P if and only if Q means the same thing as Q if and only if P. So that's essentially kind of the same question that was asked a moment ago. All right, so same thing as before that we've seen. There are multiple ways to say this. P if and only, I'm sorry, yeah, P if and only if Q. We can say P if and only if Q, Q if and only if P, if P then Q, and if Q then P. Just kind of reading the long way. Um, and okay, so it actually does touch on necessary and sufficient. So P is necessary and sufficient for Q, and Q is necessary and sufficient for P. So necessary and sufficient is basically the same thing as if and only if. It's just again a different way to say these things. And so far, this is going to summarize what we've discussed so far in the first two sections. So we have our negation. We have the little squiggle P, which means not P. We have our conjunction, which is the P and Q. We have our disjunction, which is P or Q. We have our conditional, which is if P, then Q. And then we have our biconditional, which is P if and only if Q. Right? That's what we've talked about so far. And there's nothing else to add to it, at least for the remainder of this section. Instead, what we're going to do is we're going to figure out how to pair it off. So, in mathematics, it's very important that you follow things in the order of operation, right? PEMDAS. That's very important because you can mess up your problem, right? Many times, too many times, in fact, because people know my profession, they'll see a problem on Facebook and it'll say something like 96% of people get this problem wrong. Well, if you if you just do PIM, and again, the problem is just written really stupid, and nobody with half a brain cell would ever write a problem like that. But um, if you just follow PIMDOS, then you are able to solve the problem easily, right? Uh, Kind of the same thing with this. We need to be able to follow along and group things in a way that makes it easy to read. So up top, symbolic statements with parentheses. So parentheses in symbolic statements indicate which statements are to be grouped together. So for example, we have not P and Q, right? That means that we are negating the entire statement P and Q, right? So this is it is not true that P and Q. So that's what that means. However, by contrast, if we don't put the parentheses there, then we have not P and Q, right? So only the P is negated. So and of course that says what I just said. It's not true that P and Q and then not P and Q. So we need to use parentheses when necessary. Right? So looking at example 6, we're going to let P and Q represent the following simple statements. P means that she is wealthy, and Q means that she is happy. Okay, so if and we're looking at A, we need to write each of the following symbolic statements in words. We have not P and Q. So okay, so we need to write each of the following statements. Let's see if I can. It's unfortunate that my settings never stay the same. So A reads that it is not true that she is wealthy and happy. So we say it is not true that she is wealthy, wealthy and happy. All right, and we can actually let's do it this way. We'll just do all of them like this. Okay. So B um, we have not P and Q. So uh, we would say that she is not wealthy and she is happy. So she is not uh, wealthy and she is happy. And then lastly, we have the not statement in front of the entirety of P or Q. Okay, so P or Q means that she is wealthy or she is happy, right? So since we have the not in front of it, we would say it is not true that she is uh, wealthy or happy, and that's awful. Can at least have one of those two. Uh, but again, just going by the parentheses, we just have to abide by the parentheses. And again, as you can tell, all I simply did was just read the statement left to right. That's really all I did. But I was mindful of parentheses and the negations. All right. Alrighty. So starting from the tippy top again, many compound statements contain more than one connective. When expressed symbolically, parentheses are used to indicate which simple statements are grouped together. So we're gonna run into problems where we see that we have a bunch of connectors, right? This one has an and also an if then and an if then. So we're gonna use our parentheses to help us distinguish what goes where. Okay. So looking at example 7, we have let P, Q, and R represent the following statements. So P is going to mean a student misses lecture. Okay. Q is going to mean a student studies, and then R is going to mean a student fails. So I guess we have to write it again. So let's try this Let's do this again. Does it save? No, it doesn't save. I'm sure there's a way to make it save. I've tried though. I think I'm pretty good with technology, but this one just doesn't save. It is a free program though, so there is that. Alrighty, so A, I can't really go with my laser pointer, so you're just going to follow me down there. So I'm looking down there at the bottom. I'm looking at A. It says write each of the symbolic statements below in words, and then A is the grouped portion is Q or not P. So it's going to be a student studies or a student does not miss lecture. Okay, so we're going to say, so if a student studies and does not miss lecture, I'm sorry, it's not or, that's an and. I think I said or. A student studies and does not miss lecture, then, so it's going to be if a student studies and does not miss lecture, then a student will not fail. And let's do this, and I'll go back, and does not miss lecture, the student will not fail. I think maybe if I did that, it might help out a little bit. Like I said, I'll go back and fix that on the previous problem as well. So that's what that reads. So if a student does, uh, let's actually, maybe we'll capitalize if then too, because we also talked about if thens. I don't know if this will help, but it's there if it is. So we have the if then, right, because we have the arrow. So if a student studies and does not miss lecture, then a student will not fail. Okay. Now looking at B, we have the Q, and Q means the student studies, and then we have in parentheses, if a student does not miss lecture, then a student does not fail. And honestly, that's about it. So we have a student Q, a a student studies, and then we have if a student, and then not P, does not miss lecture, then the student does not fail. Right. And I think that, yeah, that's about the best I can break it down. Let's go back on the previous page before I forget. So just like to stay consistent. It's not true that she is wealthy and happy. She is not again, I don't even know if this helps. I'm just doing the best I can. It's not true that she is wealthy, or is the other connective. There we go. Okay, so before I proceed, let's actually go back over this with my handy dandy laser pointer. So looking here again, we're just reading this left to right, and we see that we have the Q and not P bunched up. Okay, so it's Q and not P. So, but I'm starting off because I have an if-then statement here. My entire problem is if-then statement. So I'm going to say if a student studies and does not miss lecture, and that's what Q and not P means. Then, and of course, that's my arrow. A student will not fail, and of course, that's my squiggle R. And then B, a student studies. All right, so we have the if then in parentheses, so it's not the dominant symbol, which we'll talk about here in a moment. So we can just simply say a student studies, which is Q, and now we have the if. So we have the and now we're going to have an if statement. So and if a student does not miss lecture, so not P, then a student does not fail, which is not R. So hopefully that was I know it's easy to follow along. Then we're going to get to the dominance of connectives. And again, I know this is a lot of stuff all at once, uh, and I can't help you there. It's just that's just the way it is. But if I were to break this down, um, okay, so I guess this will just go its own page. If I were to break this lecture down to really, if I was a student, um, and for the record, I was a horrible student at first, right? But I ended up, being a decent student, obviously, because now I'm teaching it. But if I were to break this entire lecture down, I would start here at table 8. Table 8 breaks down everything we did for the first 5 examples. It breaks everything down for the first 5 examples. Okay, so I would lump it up into this portion and then this portion we're about to do right now. Okay, which is the dominance of connectives. And the dominance of connectives isn't that big of a deal because you're kind of told what you need to do. As long as you know that the most dominant of the connectives, and we'll talk about the dominance here in a moment, um, is the biconditional, followed by the conditional, followed by a conjunction, and the negation. So what that means is whenever we do our problems and whenever we read our problems left to right, we have to be mindful of our biconditional statements. And what that also means is we need to um, we need to group things accordingly, right? So if we were to let's look at table. Okay. So up here in bold it says if a symbolic statement appears without parentheses, statements before and after the most dominant connective should be grouped. Okay. So looking down here at table 9, looking at this statement, we have if P then Q, and then we have and not R. So we look at our dominant connective, okay, and what we need to do is we need to group everything that is, well, before or after it. And in this particular case, we're going to group the things that are after it because they need to be grouped. So we see we have our arrow is, highlighted pink. So we group the Q and not R. And now on the other side, right, we still have the if-then statement. We have the beginning part needs to be grouped, and that's what we do. Okay, so we're grouping according to the if-then statements, right? And then similarly, we would group according to the if and only if statement. So we have an if and only if statement as well as an implication. Yes? Did you need something? Okay. Um, so we have the P if and only if Q, and then that implies R. So we need to group up everything after the if and only if statement because it is the dominant one. It is more dominant than just a simple if then statement. Right? And then of course everything follows according to that rule there. Right? So let's put this into practice and just kind of get an idea, get a feel for what these dominant connectives mean. And honestly, this particular problem, it's tricky to begin with, and so I'm just gonna put this great question here because I feel like this should have been part of the um, the table on the previous page. Okay, so let's first start off with the great question. So great question. When am I supposed to use the dominance of connectives? So we only apply the dominance of connectives if grouping symbols, which are in parentheses, are not given in compound symbolic statements, or commas do not appear in compound English statements. So that's very important for this particular problem because A and B are pretty much the exact same. Matter of fact, they are the exact same, except for one little detail, and that's we have the comma there. The comma is your um, shows exactly where the break needs to happen. Okay, so if you have a comma in your statements, and again, this is a big deal. Let's put a star next to it. Very big deal. Then you don't have to worry about the dominance because it's already presented to you. So let's begin here. So we're gonna have to actually. So we have our statement is I do not fail the course. So let's say that P is I fail the course. Q will be I study hard. So study hard. PQ, and then R will be I pass the final. Alrighty. So A, I have to do this in a different color now. A is I do not fail the course if and only if I study hard and pass the final. So we have I do not fail the course. So we're gonna say not P. I do not fail the course, and then we have if and only if I study hard and I pass the final. So we have a Q and R, right? I study hard and I pass the final. So this I need to separate this with parentheses because looking at this, I could read this in at least two different ways, right? I could read it obviously in the way that's intended, or I could read, I fail the course if and only if it could be read like this. That's what I'm trying to say. It could be read like this. However, since we know the dominance of connectives, we know that everything after that biconditional statement gets put in parentheses. Okay, all you really have to look at are just these statements here. So biconditional is more dominant than the conditional, and then that's more dominant than the and ors. And then lastly, we have, and again, I wanted to point this out because we have a natural break there. We have that comma, if you can see it. So again, like I said, it's the same thing. So it is I do not fail the course if and only if I study hard and I pass the final. And I pass the final, which is R. Okay, we have that natural break, which is the comma there. So the comma tells us that we put this in parentheses, right? And that's it. So it wasn't stated on the previous page, and I don't know why, so I had to put it there. But you're going to see this at least once I've seen where you have a comma there. Okay, please be mindful of that comma. Anyways, that does conclude today's lecture. I know that was a lot. Oh, that's not what I wanted.